Okay, good morning. So I'm going to be holding the camera for part of this, and we'll set it down for part of it. But to be able to see the slide and see different things, we're going to need to hold it up. So today's lab is called It's Elemental, My Dear, and that's the standard, is PS1, MS1. I'm thinking a 6th grade level for this, a 5th or 6th grade level, just so you know. Okay, so to get started with today's lab, we are going to do a warm-up. Ideally, every student would have printed out worksheets that look like this and this. And what we're going to do is the student is going to use an online protracting tool to make a circle graph of the percentages listed here. Does that make sense?
Yes.
Okay, so to instruct you on how to use the online protractor tool, again, ideally we would use actual protractors, but this will work as well, is what you're going to do is you're going to look here at the percentage, and do you know how to take a percentage and put it in a circle graph?
Yeah.
Okay, that's fantastic. You're going to take this protracting tool, and we'll do the magnesium together. That's 2%, so go ahead and show me how that would look on this protracting tool.
Are you already filming it?
Great job. That looks like 2
Filming
degrees
it?
of a circle. So now you'll take your paper and you'll hold it up to the computer. Wow, it's like you knew how to do this already. And you'll go ahead. Yeah, be careful because the computer is a touch screen. There's not a lot we can do about that. But go ahead and trace your lines the best you can. Can you see it okay?
Yeah, the lines are a little thick, so.
You can do it. And it doesn't have to be perfect. So while you're working on this circle graph, these percentages right here have elements listed next to them, as you can see. And these elements are different elements that are found in our atmosphere. And this circle graph, what do you think the circle graph represents?
Well, I don't know. How much is...
Give it a gander.
Well, it's a chart,
Yeah.
and so it's just a visual representation of how much of each is present. So it's just basically showing like how much more oxygen there is than aluminum or something like that.
It's showing how much more it is where, though? Where do you think?
In the air?
In the air. That is an excellent guess. That is an excellent guess. And you're correct. So what I want you to do is go ahead and work on that graph. And then when you're done, I want you to color and label it. And in a group setting, this will be done with partners. Sweet.
Are you still
Yeah,
gonna record
you're still
all of
going.
it?
Yeah. I'm going to do all of it. You got this. You are doing a great job.
Oh no, I'm glitching. I'm glitching. Ah!
Some technical difficulties. You are doing great. So what element are you working on right now?
No, sodium.
Sodium.
I was gonna
Have you
say
labeled the other elements that you've done?
potassium. I didn't.
That might be a good idea because
Both the same
sodium and potassium, their degrees are really close, right? 2 and 3.
Yeah, potassium and magnesium are the same, so I wasn't labeling them yet.
That's okay. No worries. It just might make it easier for later.
Should have gotten
Is there a ruler in the drawer?
a ruler. There's a ruler in this drawer.
Go ahead and use that ruler.
Well, yeah, I know, but I've already drew.
Is that a protractor?
Guess who found it?
No way. Well, you can go ahead and use that instead of using the online tool. Since we didn't know we had that. You can just... You haven't... Here, just give that to me. We'll just put this over here for now.
Okay.
Okay, you're doing great.
Oh, this isn't a ruler. This is a paint thing.
It will work.
Okay.
Okay. we'll go ahead and switch back to our slide.
Dope.
Just so we're ready for the next part of the activity. Do you think it will go faster now that you have a protractor and you're not using the computer?
Most likely.
Okay.
Okay, I'm gonna redo these. Because they be ugly.
Okay. While you do that, and you might not have time to color it, but why do you think it's important to know how much of each element is in the atmosphere?
Well, probably because I'm a really bad example for a student, but probably because I don't know, maybe it's so that we actually know what we're breathing in on a daily basis.
That might be helpful, but
I want to know that I'm breathing in 8% aluminum.
well, technically, you only use the oxygen that you breathe in. And so that might be important, but does it really affect you to know what exactly you're breathing in? Probably not. Really, what might be helpful to know how much of each element is in the atmosphere is when you're talking about different things later on, like molecules, and we're going to talk more about that later on.
Molecules.
Sure.
Sorry, that was a bad joke.
And I think it's a fun way to introduce elements around us, because we've talked a little tiny bit about the periodic table.
We have?
Air quotes. Yes, we have. We've talked a little tiny bit about the periodic table, but we haven't gone into very much depth about how to read it or about what the elements mean. So I think it's interesting to see, when we briefly looked at the periodic table before, which is here, there's all of those elements, right? Can you look up at that?
Yes.
And are all of those elements in our atmosphere?
Not. Well, probably. No.
No. So, well, yeah, no, there's not that many elements in our atmosphere. And not even all of those elements exist naturally, which is something that we'll also talk about later. And so really, this lab today is going to be about figuring out what the purpose of elements is, and how many elements there are, and what they do, and how they work together. So, go ahead and keep working on that. How's it coming?
Poorly. I'm really bad at drawing. Charts, apparently.
Did you start over again?
Yes, Miriam, it has to be perfect.
It doesn't have to be perfect.
Yes, it does.
Okay, well, tell you what, how about... How about I let you work on that for 3 more minutes, and then we're going to go ahead and move on with the lab, okay?
All right.
Sound good? All right, sounds good.
Good handle,
Start
Mary.
recording.
Oh, stop. By the way, my name is Miss Williams.
Yes, Miss Williams, yes. By the way, your circle stinks.
Sorry, I did the best with what I have.
Which is nothing.
You gotta be good. Gotta go on.
So will you go ahead and do oxygen next, please? I want to make sure that you at least have oxygen on there. Because that's going to be important for later on.
Nah.
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 There's my favorite student of the day making a bad pun. Well, you know what I have to say to that? Okay. All right. Go ahead and do oxygen. This is also the point in the lab where, if working with groups, I would be going around making sure that everyone understands how to use a protractor. She's got a pretty good handle on it. It's just like the online one that we went over together.
Also, this circle doesn't match my angles. Look how much oxygen there is. Did you know there's such a thing as oxygen bars? There's places you can go to get high on oxygen, but you don't get high. You just get refreshed.
Hold up. You know what? I actually have been doing... I instructed you to do the degrees wrong, because how many degrees are there in a circle?
360.
Yeah. And we're treating it like there's 100 degrees in a circle. But that's okay. So what I want you to do now,
Cry.
since I messed up that and I forgot that step in instruction, I want you to mark 100 degrees on here. Can you do that really quick before we move on?
Yes, I can.
And then we'll look at the elements that you had time to mark down.
Just for you.
We have some nice relaxing music going in the background as she works. It's mom singing.
Yes, I know. I got that.
Okay.
That's what my soul looks like.
So, go ahead and look at that. So we marked 100 degrees. So really we're just looking at this, right? This part?
Yes. There's nothing there because I didn't get
Because you didn't get there yet. And that's okay. I would, if you want to fill that out later, this will be available. If you don't, that's also okay. Really, mostly what we're looking at is the difference between oxygen and the other elements that are there. And which has more, oxygen or the other elements?
Well, I mean, you say the other elements, but do you mean all the elements together or all the elements separated? Because all the elements together, it's more because it's 53%. But I'm
No,
just
that was a
stating
good point.
The obvious.
That was a good point. But if you put oxygen next to them individually,
Well, yeah, then there's more oxygen.
oxygen is the most dominant element in the atmosphere. Okay, so remember that. We're going to come back to that later. Right now, we're going to go on. Remember I said we were going to talk more about the periodic table?
Yeah.
So this is like an element on the periodic table as it's listed. So we kind of went over this last class. This is an element. Thank you for correcting my language. This is an element. So this is what it looks like. You can recognize it. But this is what each of the things means, okay?
Yes.
So the atomic number is listed in the top left corner. The symbol is in the middle. So the symbol here, oops, I didn't mean to do that. The symbol here is H for hydrogen. Are you taking notes? That
Sure.
is awesome. That is awesome. Keep doing that. The name is, I keep touching the computer. The name is hydrogen, and that's right here. And the atomic weight is listed underneath there. So what do you think the atomic weight is? I'm gonna let you think about that. Don't say it out loud because we're gonna look at it right now. Just think.
What do I think it is?
Just think.
Well, it shows it.
No, what do you think it means? Sorry.
Oh, well.
So here, the atomic number is how many protons there are.
Yes.
And the atomic weight is how many protons and neutrons there are together. So in hydrogen, how many protons and neutrons are there together?
1.008. Wait, so does that mean there's 0.008 number of neutrons? Because there's one proton.
That is an excellent question. No, so it weighs slightly more than 1. So usually you'll round. I should have said that. Thanks for catching me on that. So 1 proton weighs about 1 proton and 1 neutron individually weigh about 1 atomic mass unit, which is what this is called. So there's 1 proton, right? Because there's 1 proton and there's no extra neutrons, right?
Yes.
Does that make sense? If I showed you a random element on the periodic table, could you tell me how many protons and neutrons there are in it?
Yes.
All right.
All of them.
Then I want you to pick just one, actually, for time purposes. Pick 1 random element on the periodic table, and I want you to take a piece of paper, which I can't get down. We put a notebook on top of it. Take a piece of paper, and I want you to color it on here, and I want you to label it with the number of protons and the number of neutrons and the name. No, not the name, because the name's not listed on there. Sorry.
The name is right there.
Oh, it is. It's just in a different spot. Good eye. I was counting on using the periodic table in our classroom, so I added this very last minute, and I didn't look at it very well. We're seeing that. All right, go ahead and...
Ah, yes. That's the one I wanted. We named an element after Einstein. Oh,
How do you know it's named after Einstein?
because it's called Einsteinium,
Good job.
or Einstein. Yeah, Einstein. Einsteinium. I don't know how to pronounce it.
Here's a question.
What?
Do you think water is an element? Is it on the
No.
periodic table?
Water is a mixture of elements because it's H2O.
That's right. A lot of people know that water is H2O.
So because it's a hydrogen and oxygen, it's two different.
Yep, we're going to talk about that in just a minute as well.
Even though, well, I mean, technically it is an element. Like it's one, like fire, rock. Yeah. Those elements.
So the unit down at the bottom with the protons and neutrons together is called the atomic mass. Can you tell me how many neutrons and how many protons there are?
It says right there. The key.
Yeah. Can you tell me how many neutrons and how many protons there are in Einsteinium?
There's 99 protons and I'm so bad at quick math. Bad at quick math. Oh wait, no. I gotta. So that would be 3. What am I thinking? I'm stupid. So that would be 5 and that would be 4. I mean 3. And then what? 153 neutrons.
And how did you come to that conclusion?
Math. You literally saw me doing the work.
I did. I just wanted you
Stop.
to explain to me in words why you did that.
Because if it's protons and neutrons, if you take the both of them together and you minus just the protons, then you'll find the neutrons.
Good job.
Yeah.
That's awesome. Okay. All right. We are going to now. So now, do you think you understand elements pretty much? If it's on the periodic table, it's an element, right?
Yeah.
And it's made of protons and neutrons. That's all we're going to talk about. We'll have a later unit on other things that make up elements and atoms. Okay. So now we are gonna watch a
Hey,
video
it's Bill Nye.
by Bill Nye the Science Guy. That was great recognition. All right, okay, we're gonna watch this video. And as we watch this video, I want you to think about, so you see here's written H2O. You already told me that's not an element, right? So we're gonna find out what that's called, and we're gonna find out why it does that, and then we are going to make some of those. Okay?
Hydrogen dioxide.
And that didn't play it. How do you play? Press play. There we go. All right.
Wait, is it?
Does this have the volume on?
Because atoms are the basic building blocks of all matter. Atoms are like the letters in the alphabet of the universe. So look what happens when we combine these letters. We get words. Atoms are like letters. And molecules are like words in our universal alphabet. All matter is made of atoms and molecules.
Hey, science guy. Even a banana cream pie?
Oh yeah, even a banana cream pie. How do we know that atoms combine to make molecules? Well, please, consider the following. This is H2O. Water. 2 parts hydrogen and 1 part oxygen. When the atoms come together, they stick. Okay, but how do we know? Well, take a look at this. In here we have some water. And we're passing electricity through. When we do, we get 2 gases. If we let it go long enough, there'll be no liquid left at all. Just the gases. And they're pure. They're each made of just one kind of element. On top of that, there's twice as much of this gas as this gas. By doing a lot of experiments like this, scientists have figured out that, H2O is 2 parts hydrogen and 1 part oxygen, with the hydrogens on one side and the oxygen on the other. Kind of like mouse ears. See? H2O is great. The ocean is made of H2O. You and I are full of H2O. It's wild. It's wonderful. It's water.
Okay. So, how are molecules made?
A combination of atoms.
Right. And so how he put on the board, he put H2O because it was 1 hydrogen and 2 oxygens, right?
Yes.
So, that being stated, we have this chart right here, and it's got different molecules on it. It has, are these molecules right here?
No.
What are they?
They're atoms.
Right, because they're just alone, right? So, this one right here is PBS, right?
Kids.
Yeah. Yeah. So, PBS has what in it? What do you think?
I don't know.
You don't have to say the name, just because I didn't tell you the name. How many PBs does it have in it?
1.
How many S's does it have in it?
1.
That's right. How about this one? How many Fes does it have in it?
1.
How many S's does it have in it?
2.
Right. So if we're looking at a periodic table, we can find the names of those, right? But we're just gonna look at this and we're gonna make some of these. So before I made water on a cup, and I don't have the cup anymore, so we're gonna use a stuffed animal.
Oh, we're gonna use rock.
And we're going to use these pins to represent different atoms, okay? And the different atoms have different colors. So these pins are really sharp, so be very careful with them. Don't poke yourself, and only put it in the stuffed animal or in the tray, okay? Be very careful. Okay, so make H2O. Let's say yellow is hydrogen and water is blue.
Water? You mean oxygen?
Oxygen is blue. Good catch. Good job. Now make this one. And let's say calcium is red and phosphate. I don't think that's phosphate.
Are you
But
sure?
it's not working, Hilda.
Sure. Wait, okay.
Wait, I got it.
You went too far back.
Okay, let's find F. And fluorine.
Fluorine! Dang it. I was wrong.
Calcium is red and fluorine is black.
Black like my soul. I like my men black like I like my soul. You hear my joke?
So, these atoms come together to form molecules, right? Which do you think weighs more? The one that you just made or PBS?
The one that I just made.
Why do you say that?
Because PBS is only 2 and the one that I just made is 3.
Yeah, that's a really good guess. I'd have to look at the actual atomic mass units, but generally, if it has a lot more molecules, then it's going to weigh more, right? Like, let's look at hornblende, which I wanted you to have a clean copy of this, but that's okay. Do you think hornblende weighs a lot or a little?
I think it's a funny name. A lot.
That's right. Okay. And because it has a lot of elements in it, right? So that's how atoms and molecules work. And really quick, just for fun, so at the beginning we made a circle graph, well, more like a fraction graph, of the elements in the atmosphere.
It's called a pie graph.
And I want you to take it, what you have, and I want you to look at this and tell me if you see any correlations between the minerals and the molecules that we have here and the graph that you made. Can you do that, please? Is there a lot of magnesium?
Well, okay, so there's magnesium in...
Just look at the top part, please. Actually, that's why I crossed those out.
there's only one.
Is there a lot of
Salt?
sodium?
Yes.
Is there a lot of oxygen?
Well, there's not a lot of sodium, but...
No.
Well, yeah.
There's way more oxygen, right?
Yep.
So that's pretty interesting that oxygen is
That's
in all
because-
those molecules.
It's because there's a lot more oxygen than there is the other in the atmosphere. So, wait, okay, so I have a question.
Go
So
for it.
if I just swallowed hydrogen and I just swallowed oxygen, could I live off of that instead of drinking water? Because, I mean, technically...
No. And that concludes our lab for today. In conclusion, oxygen is super relevant, and it's in a lot of different things. It's in the atmosphere, and it's in a lot of different molecules that make up the Earth's crust. And atoms are all around us, right? But when atoms work together, they make up molecules. And there you have. That concludes the lab. Thank you for coming. Have a nice day.